Okay, parameter or statistic. In a survey conducted in the town of Atherton, 28% of adult respondents reported that they had been involved in at least one car accident. This is a survey, guys. You don't survey every single one, so that's a statistic. What about number 2, guys? Who can help us out? What do you think this underlying number is represent? Parameter or statistics?
Parameter.
Yeah, because it says of the residents, all the residents, guys. I didn't need to say of all the residents. Once you see the in there, that's an indicator of population. Yeah. If it says 51.7% of 500 residents surveyed, then it will be a statistic, but it says all of them, so that's a parameter. Quantitative or qualitative, the number on the shirts of a boys football team, it's a label, guys, so that's a qualitative. You see, that was in your assignment, and then it is in the study guide. Height of a tree, ratio. Height, weight, age, money, all ratio, guys. Except for temperature, that's an interval, because 0 means something there. Determine the level of measurement of the variable. Student sport, it's nominal. Number 6, 35 math majors, 47 music majors, and 37 history majors are randomly selected from 276 math majors. So we have this, guys. We have the big 3, and then we select a few from here, a few from there, and a few from there. So that's stratified. Number 7, a lobbyist for the oil industry assigns a number to each senator and then use a computer to randomly generate 10 numbers. The lobbyist contacts the senators corresponding to these numbers. What sampling technique? When you do something randomly, guys, it's a simple random sample. That's a very good sampling technique that to use. Number 8. Okay, let's see. A local hardware store wants to know if its customers are satisfied with the customer service they receive. The store posts an interviewer at the front of the store to ask the first 120 shoppers who leave the store, how satisfied on a scale of 1 to 10 were you with the store's customer service? Determine the type of bias. Do you have any comments, guys, on this? What do you think, if there is bias here, what kind of bias would be? Any suggestions? You know, the type of bias here, it's the first 120. Probably the ones who come to the store at the early morning hours are probably the contractors. They're not like regular customers. So not distributing the interview over the hours of the day could create, you know, just some kind of bias, because the late evening customers probably are different from the morning customers, different from the afternoon customers. Number 9. The results of a survey about recent judicial appointment are given in the table. Construct a relative frequency distribution. I mean, guys, that should be very easy. All I'm asking you to add a new column and call it relative frequency. You just need the total first of all. So I got 48, 55, 60, 80, 200. So that will be 35 over 200. That would be 13 over 200. That would be 7 over 200, 25 over 200, and 120 over 200, and you are done. That's the relative frequency.
I have a question.
Yes.
On the test to find the relative frequency, are we going to have to actually divide the numbers, or can we just put them?
Yeah, I will say if I want you to. If I don't say, then you do this, and then I have to mark it right.
Okay.
But if I don't say, yeah, you do it any way you like. But if I say round to 2 decimal places, you just round to 2 decimal places.
Okay.
Good question. The class width is the difference between 2 consecutive lower class limits. And for example, guys, if you have 1 to 7, and then you have 8 to 14, the class width is the difference between these two. This is called the lower class limit, and this is called the upper class limit. Lower, upper. Or between the, if a student put also the difference between 2 consecutive upper class limits, I will mark this correct as well. Okay, number 11. Determine the number of classes in the frequency table below. 1, 2, 3, 4, 5, done. All right. Now let's go back. Some more questions. Number 12. A researcher records the number of employees for each of the IT companies in the town of Westmore. Find the class width. Well, the class width, guys, we just said it, it's a difference between 2 consecutive lower class limits. So difference between 250 and 500 is 250. Maybe a student wants to do 250 and 0. Yes, that's 250. Maybe a student wants to do 749 minus 499, that's 250, and so on and so forth. Okay, so it doesn't matter how you do it, as long as you do it this way, guys. Don't do it that way, that will be wrong. Because look, if you do 499 minus 250, get 249, that's not the class width. The class width is determined vertically. Okay. For the data below, construct a relative frequency distribution. I already done the frequency distribution, so relative. I just put relative frequency. And then we need the total, guys, 13, 25, 30, 49. So it's 5 over 49, 8 over 49, 12 over 49, 13 over 49, 11 over 49. And let's say, guys, he wants a cumulative here. Let's do that. So you just put the 5, then the 5 plus 8, 13, then the 5 plus 8 plus 12, 25, then the 5 plus 8 plus 12 plus 13, 38, and then finally the total, which is 49. That's a cumulative frequency. Number 14, the number of home runs that Mark McGwire hit in the first 13 years of his Major League Baseball career were listed below. Construct a stem and leaf plot. No problem. Okay. 1 second, please. Okay, so I have single 2-digit numbers here. So we have to make this a 0 to make it all 2-digit. So guys, you do this 0, 1, 2. We go as far as 54, 70. Actually, there is a 7 as well. Okay, So for the 0, I have a 3, I have a 9, and a 9. Any ones? No. Any 2s? Yeah, 22. 3, I got 2, 32, 33, 39, 9 again. 4s, I got 1, which is the 9, and a 2. For 5, you have what, guys? 52, 58, 60, I don't have anything, and 70, I have a 0. And then you put a key here, 0, 3 means a 3. That is the stem and leaf plot. Now, probably a question you ask me, if there is nothing, there are no 1s, 10s, or 60, do we have to include them? Yes, guys, you have to include them just to say that there is nothing there. So this is like, a bar with no height, 0 height, but that's how the stem and leaf would be like. And since I see 2-digit, then everything else has to be 2-digit to be consistent. And that's why I put a 0 here, a 0 there, and a 0 there. Describe the shape of this distribution, number 15, guys. You can see this is skewed left, as you notice. When the tail is toward the left, it is skewed left. Number 16 is either histogram symmetric. None of them are symmetric. They're both skewed right, as you can see. This is to the right, to the right. All right. Number 17. Okay. The following graph shows the number of car accidents occurring in one city in each of the years 2006 through 2011. Year 1 is, so this is 2006, 7, 8, 9, 10, 11. The number of accidents dropped in 2008 after a new speed limit was imposed. So you can see right here. How is the bar graph misleading? Do you guys see where this bar graph is misleading? This bar graph is misleading because the vertical line doesn't start at 0. It doesn't give you the true impression about the, so like you see here, it looks like a major drop, but look, this is 120 and that's 100. When you don't start with 0 on the vertical line, the graph will become some kind of misleading, and that's the reason why it is misleading. So look always for this number, guys. If it's not 0, the graph is misleading. 18, the high temperature in degrees Celsius each day over the 3-week period were as follows. Compute the mean, median, and mode. So just put them in L1, guys. The mode, the calculator doesn't do it for you. You just have to figure out the one that repeats the most. And can you guys tell me which value repeats the most here?
Two. 21.
Which one?
21.
21, let's see. 1, 2, 3, 4. Yeah, I think so. So 21, and then 22, how many times? 20, how many times it repeats? 3 times. Yeah, 21. Yeah. And mean mode, you put them in the calculator. 19, that's an important question, guys. We talked about it when we did chapter 2. For the distribution drawn here, identify mean, median, and mode. Remember, the mode is the value at the highest peak. You can see the highest peak is right there, so that must be the mode. And remember what I said, guys, in a skewed distribution, the mean is always the closest to the tail of the distribution. This is the tail of the distribution. So which value is closer to the tail? It's C, that must be the mean. And B definitely will be the median. In a symmetric distribution, they are all the same, mean, median, and mode, but in skewed distribution, that's how it is. So I might give you a question like this, for example, on Monday. And I give you the three values, M and P. And I ask you to identify each. So first of all, the highest peak, that's M, that's the mode. And then P, because it's closer to the tail, that's the mean. And then N would be the median. Okay. 20. In distribution that are skewed to the left, what's the relationship between the mean, median, and mode? Oh, well, we'll just talk about it. So the mean, if this is a skewed left distribution, the mean will be always less than the median. And in this one, guys, mean will be greater than the median. You don't need to know their values, but you can. And the mode is the value at the peak. If the graph of a distribution of data shows that the graph is symmetric, then the mean is the same as the median. Okay. Compute the range 22 of this data set. The range is the difference between the lowest and the largest value, guys. Max minus minimum. Okay, so that will be 22 minus 11, which is 11. That's the range. Okay. 23. The amount of television reviewed by today's youth is of primary concern to parents against watching TV. 300 parents of elementary school aged children were asked to estimate the number of hours per week that their children watch television. The mean and the standard deviation of the responses were 17 to 4 and 4. So the mean is 17 and standard deviation is 4, respectively. Parent against watching TV constructed a stem and leaf plot display for the data that showed that the distribution was bell-shaped. Give an interval around the mean where you believe 95% of the television viewing times fell in the distribution. This is the empirical rule, guys. And the 95% is when the values are within 2 standard deviation of the mean. And how do we do that for the 95%? Look. This is the mean, which is 17. Add 2 standard deviation, that goes to 3. So that's 21 plus 4, 25 plus 4, and then 29, which I don't need. Subtract 1 standard deviation, that will be 13. Subtract 1, that will be 9. And subtract 1 will be 5. So the 95%, guys, according to the empirical rule, is within 2 standard deviation. So it's between 9 hours and 25 hours. That's the answer. That could be a multiple choice question and just select the correct answer. So from 9 to 25. If I give you the same question on the test and I ask you, construct an interval for the 60-80% of the data, the 60-80% is within one standard deviation, will be between 13 and 21. And if I ask you 99.7% of the data, then it will be from 5 to 29. Okay, that's the empirical rule. All right, 24. Many firms use on-the-job training to teach their employees new software. Suppose you work in the personnel department of a firm that just finished training a group of its employees in new software. and you have been requested to review the performance of one of the trainees on the final test that was given to all trainees. The mean and the standard deviation of the test score is, so the mean is this 82, and the standard deviation, guys, is 2 respectively. And the distribution of the scores is mound-shaped, means bell-shaped and symmetric. Suppose the trainee in the question received a score of 77. Change this to a z-score. So all this language, guys, to change it to a z-score. So z will be 77 minus 82 minus the mean divided by the standard deviation. 77 minus 82 is what, guys? -5 divided by 2, which is -2.5. Based on this z-score, guys, if you were the boss, would you keep this trainee or you would fire that person? Who can answer this question? He was doing training and his z-score was -2.5. Any comments? That's a very low z-score. It's way below the mean, guys. It's an unusual score for a trainee. So probably this trainee would not get a second chance to continue on the job. Okay, 25. A study was designed to investigate the effects of 2 variables, a student's level of mathematics and anxiety and teaching method on students' achievement in mathematics course. Students who had a low level of math and anxiety were taught using a traditional expository method. The students obtained a mean score of 370 and a standard deviation of 50. Find and interpret the z-score. Again, this is about z-scores, guys. So the z-score of a student who scored 490. So the z-score, guys, is the value 490 minus the mean 370 divided by 50. So that will be 120 divided by 50, which is 2.4. That's a good z-score. Any questions about the z-score? 26, when results from a scholastic assessment test are sent to test takers, the percentile associated with their scores are given below, are also given. Suppose a test taker scores at the 94th percentile for their verbal grade and at the 29th percentile for their quantitative grade. Interpret the results. Okay, 94th percentile, guys, means that this student did better than 94% of the students on the verbal grade. 29th percentiles means the students did better than 29% of the students on the quantitative grade. It also means 29, if you subtract from 171%, 71% of the students did better than this particular student. So that's what a percentile is. So when I tell you next week to a students, I said that you scored in the 85th percentile, it means that you did better than 85% of the students. 27, the commute time in minutes of 30 employees are listed below. Find a Q3. Okay, Q3. I'm gonna try to do this by hand, guys, because the numbers are arranged in order. So I have 30. My median will be between the 15th and 16th. So that's 10, 11, 12, 13, 14, 15, 16. That's my median right here. Okay. So we got 15 values to the left of the median, 15 values to the right. So Q3 will be the middle of the second half. Well, I got 15 values, guys. How do you find the middle of 15? You add 1, which is 16, divide by 2, 8, count to 8. 1, 2, 3, 4, 5, 6, 7, 8. That's the Q3. And if I ask you to find a Q1, 8. 1, 2, 3, 4, 5, 6, 7, 8. And if you want to know what the median is, guys, Q2, It would be 70 plus 74 divided by 2. Minimum, that's the 5-number summary, that's 31. And maximum will be 99. Okay. 28. 11 high school teachers were asked to give the number of students in their class. The sample data follows. Find for the 5-number summary. You can also do the calculator for this one if you want. I'm going to just demo this with the calculator. It's very likely you're going to have a question like this. Okay, I'm going to clear the lists to make him. Okay, so let me put him. If you don't want to do it by hand, that's fine, guys. All right, and here's how we find the mean and the median. You go stat, calc, one variable statistics. Okay, see, this is L2. I need to change it back to L1. So you press the second key and number 1. Okay, so the 5-number summary. Minimum is 19. Let's list them. Q1 is 21. Q2, which is the median, guys, 28. Q3 is 31. Maximum 36. All right. 29. A random sample of sale price homes yielded the following summary information. Comment on a home that had a sale price of 429,000. Okay, so we have the minimum, we have the maximum, we have a Q1, Q3, and the median. Want to check if this is an outlier or not, guys. That's what the question is. So probably I will tell you, check if this is an outlier. So we do Q3 minus Q1, which is Q3 is the 75 percentile. So 166,000 minus Q1, which is 80,000. So that's 86,000 multiplied by 1.5. So that will be 129,000. Now take a Q1 and subtract 129,000 and take a Q3 and add. Q1, guys, this is the Q1. So 25% means the Q1. 75% Q3, and median is 50%. Okay, so 80,000 minus 129,000 is negative 49,000. And Q3, guys, is 166 plus 129. So it will be 295,000. All right. So actually 429 is an outlier. There's no outliers here. Anything beyond 295 is an outlier. Okay. Next, we'll get into chapter 3. That's one more question, and then we'll get to chapter 3. SAS was used to compare the high school dropout rates for the 30 school districts in one city in 2010 and 2012. The plots generated for these dropout rates are shown below. Compare the center of the distribution and the variation of the distribution for the 2 years. Okay, what can we say here, guys? What's where do we see more variation? We see more variation in 2012 than 2010. If I ask you to find the median of this one, this is the median of the 2010 right here. It's a lower median in 2012 right here, you can see here. But it looks like there's more spread out of data in 2012 than 2010. I could also ask you a question, guys, which one has a larger median? You can easily tell me that in 2010, it's a larger median than 2012. You can see the median here and the median there. I could ask you to find the interquartile range, Q3 minus Q1. You can see Q3 right here and Q1 right there. It's a lower interquartile range than right here. Look, this is a Q3 and this is a Q1. Okay, now we're getting to chapter 3. If ABC are the only possible outcomes of the experiment, find the probability of D. Can a student tell me what should be in the blank there? You remember the sum of all probabilities have to add up to 1. So if I got 1/14 here, 1/14 here, and 1/14 in C, and I know the only possible outcomes are A, B, C, D, what would be the probability of D? Who can say that? So what would be, what ratio, what answer would you put in D? Remember, if the probability of rain is 90%, the probability of no rain is 10% because they have to add up to 1. So what would be the value here in order for all the values to sum up to 1? Any answer? No, 1/14. If you put 1/14, they add up. 1/14 plus 1/14 plus 1/14 plus will be 4/14. Yes, 11/14. And now add them up, guys. 1 plus 1, 2 plus 1, 3 plus 1, 11. 14. 14/14 is 1. True or false? The probability that event A will occur is number of successful outcomes divided by total number of all possible outcomes. That's the definition of probability. I call it in the book, guys, favorable outcome. Yes, that is true. Okay, 33. The table below represents a random sample of the number of deaths per 100 cases of certain illness over time. If a person infected with the illness is randomly selected from all infected people, what's the probability that the person lives 3 to 4 years after diagnosis? Okay, this one. That should be a very easy question, guys, according to this definition right here. Your favorable outcomes is 35. And how many did he say? 100 altogether. So it's 35/100. 0.35. Done. 34. A single die is rolled twice. What's the probability of getting two numbers whose sum is greater than 10? Okay. You know, guys, the number of outcomes is 36. You know, don't need to add them because we talked about them. We have 6 times 6, so it's 36 right here. Now, sum greater than 10, you have to look only for the order pairs that work in your favor of getting a sum of greater than 10. Greater than 10 means 11 or 12. We can go beyond that. So let's see where we have 11. That's 11. That's 11. And that's 12. So if I ask you guys to do this to 2 decimal places, for example, or 3 decimal places, just do 1 divided by 12. And it would be, for example, to 4 decimal places. That's 34. This is a very popular question, guys. Two dice are rolled. I could ask you what's the probability of getting a sum of 7, for example. Let's do that. Sum of 7. Okay, 1 and 6, that's 1. 2 and 5, that's 1. 6 and 1, that's a 1. 1 and 6, that's a 1, that's 4. And 3 and 4, and 4 and 3. So I got 6 out of 36. Your answer will be 6 divided by 36. That's how you answer them. All right. 35. In a game of roulette in the United States, a wheel has 38 slots. 18 slots are black, 18 slots are red, and 2 slots are green. We watched a friend play roulette for 2 hours. And that time we noted that the wheel was spun 50 times and that out of those 50 spins, black came up 22 times. Based on this data, probability of black is 22 over 50. This is what example of probability? This is the classical, guys. You have a classical, you have empirical when it gives you a table, a survey results in a table that's empirical, or when he make an intelligent guess that's subjective. So this is the classical definition of probability. 36. The table lists the drinking habits of a group of college students. If a student is chosen at random, find the probability of getting someone who is a non-drinker. Okay, who's gonna help us with this? That should be very easy. Non-drinker. What would be the probability of getting a non-drinker?
Uh, 322 out of 387.
You got it. Any questions about this, guys? You go to the total of non-drinkers. These are the ones that work in our favor. 322 divided by the grand total. Let me ask you some more questions because, guys, I can tell you 100% you're going to have a question with a table like this and several parts. What is the probability of selecting someone who is a man? So total of men 171 divided by the grand total 387. What is the probability of selecting someone who is a man and non-drinker? Man and non-drinker, guys, you have to see where they meet together. Man and non-drinker, they meet right here. So it will be 135 divided by 387. Let's ask another question here, which is conditional probability. What is the probability of selecting someone who is a man given that he is a non-drinker? Who can give me the answer here? Probability of selecting a person who is a man given that the person is a non-drinker. What goes in the denominator?
322.
Exactly, 322, because we want to select from the group of non-drinkers. Exactly. This is what I told you last time, guys. What comes after given is your denominator, so 322. For the top one is easy, guys. Find where the man and the non-drinkers intersect. They intersect at 135. And that would be your answer. Here is another example. So this is now we're reviewing chapter 3. What is the probability of selecting a person who is a non-drinker given that the person is a man? So I'm just gonna write it down. Non-drinker given that the person is a man. You see, I switched the value, the words. So now your denominator is the group of men because we have to select from the group of all men, which is 171. But look, the numerator doesn't change, guys. Non-drinker and man, the intersection is still 135. So when you have the word given in the problem, remember what comes after given should be your new denominator, not the grand total, which is 387. Okay. We will come to the OR in a little bit. We'll do a question on additive rule. 37. You roll 2 dice and total the up faces. So sum the up faces. What's the probability of getting a total of 8 or 2 up faces that are the same? Okay, we know, guys, for 2 dice, without even thinking, your denominator should be 36 always. Now we want to see how many outcomes would work in our favor. Total of 8. What could we get to get a total of 8? 2 and 6, 6 and 2, 5 and 3, 3 and 5. Anything else, guys, that will give us 8? Don't say 1 and 7. There is no 7 on the face of the die. Only 6. 1, 2, 3, 4, 5, 6.
4 and 4.
Okay, 2 up faces that are the same. 4 and 4. Now he says you would win if you get up faces that are the same. So we need 1 and 1. 2 and 2. That's a win. 3 and 3. 4 and 4. I already counted that. 4. 5 and 5. And 6 and 6. Okay, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it'll be 10 over 36. 1, 2, yeah. Okay, 2 events are. I repeated this twice. 2 events are independent if the occurrence of one event does not affect the occurrence of the second event. That's what independent event. 2 events are mutually exclusive, guys, if they cannot happen at the same time. So that's the difference between independent and mutually exclusive. Okay, suppose that events E and F, we're doing this now, are independent. Probability of E is 0.3, probability of F is 0.5. What's the probability of E and F? I gave you a formula on Monday, guys, that the probability of A and B, if the events are independent, equals probability of A times probability of B. And here, guys, this answer will be simply 0.3 times 0.5. Unmute yourself, please. All right. 40. A bag contains 10 white, 12 blue, 13 red, 7 yellow, and 8 green wooded balls. A ball is selected from the bag. Its color is noted, then replaced. You then draw a second ball, note the color, and then replace it. What's the probability of selecting 2 red balls? Oh, okay. Let's do this together, guys. First of all, if you pick one ball and put it back, the events, and then you pick another one, the events are independent because you put the ball back in the container. So it's the events are independent. He wants the probability of selecting 2 red balls, meaning probability of selecting 1 red and another red. So since the events are independent, guys, we're going to do the first probability, we're going to do the second probability and multiply the 2. So what's the probability of red? Who can tell me what the answer is? What's the total? I have 10, 12, 22, 35, 42, and 50. So 50 at the bottom. And what's the probability of red? It's 13 red, 13 over 50. So your answer, guys, for this problem will be 13 over 50 times 13 over 50. And he wants the answer to the nearest 10,000, so 4 decimal places. Let's do that. 169 divided by 2500. You multiply 13 by 13 and 50 by 50. So I got 0.0676. Okay, let's say I give you the same question on the test, guys, but I'll ask you, what's the probability of selecting one red ball and one yellow ball? Can someone give me the answer? One red and one yellow. How would you do this?
Would you multiply 13
Over 50
times 7 over 50?
Exactly. 13 over 50 times 7 over 50. If I give you the same question in the test, I said two yellow, guys. 7 over 50 times 7 over 50. Okay, 41. The managers of a corporation were surveyed to determine the background that leads to a successful manager. Each manager was rated as being either good, fair, or poor manager by his boss. The manager education background was also noted. The data appear below. Given that a manager is a good manager, what's the probability that the manager has some college background? Okay, so probability of some college giving, this is for giving, guys. I'm going to put the given next. Good manager. Who would like to give us the answer? I started with given first, guys. So what comes after given, remember, should be your denominator. So given that the manager is a good manager, we have to have the total of good managers, which is 39. And now I want some college and a good manager right here. Where do they meet?
At 6.
At 6. That's the answer. 6 over 39. Let's add another question about the OR here. If I give you this table, guys, and ask you what's the probability of having good manager or high school degree? You see the OR now? Okay. Before I do that, let me tell you what the definition we put for probability of A or B. We say it's a probability of A plus probability of B minus probability of A and B. And as I said on Monday, guys, if you like to have some written notes by hand, that would be allowed on the test. So I'm going to allow you to do that. So for example, if you want to write this formula, that's fine. Although I will provide a formula sheet, so you'll have all the formulas. So your good is A here, and high school degree is B. So we need probability of good manager. Okay, what is the probability of a good manager? No conditions here, guys, no conditional probability. So good manager will be 39 divided by 160 plus. Now we need a probability of a high school degree. Okay, can a student tell me what would that answer be for high school degree?
12.
Minus, always with or you have to would minus the intersection. High school and good, which is 4, guys. So 47 over 160, that's the answer. Okay, evaluate 9 factorial divided by 7 factorial. Okay, 9 factorial, as I told you on Monday, it means 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9. And this one, guys, means 1 times 2 times 3 times 4 times 5 times 6 times 7. You know what, guys? You can cancel actually everything. And what's left? 8 times 9, 72. Or you don't want to do this, that's fine. Go here. Put 9 on the home screen. Go to math. And go to number 4, probability. So math, then prop. and then enter, you got the answer. Then go to 7, math. And now take 362,880 divide by 5040. You get 72. That's another way to do it. 43. Let's see, do we have any more questions there? Oh, we're almost done with this one, and I'm gonna let you work on the other one on your own. Okay. There are 9 performers who are to present their acts at a variety show. How many different ways are there to schedule their appearance? So which one comes first? The first one, the second, the third? So order is important. Does anyone know how to do this one? That was the last thing we discussed in chapter 3, permutations and combinations. So we have 9 performers, and how many ways we can schedule the appearance of the 9 performers? How would you do this, guys? Like the first performer, guys, can choose whether to be the first, the second, the third, the fourth, the fifth, etc. He has 9 choices. The second one, he will have 8 choices because the first one already done the work. And then the next one will have 7 choices, 6 choices, 5 choices. And the order is important here. When the order is important, it's a permutation. So will be 9, P9. P is a permutation, or you can, so, and if you go to your calculator and you want to do this, that's how you do it. You just put 9 on the home screen, and then you go to math, you go prop, and it's MPR. P means, I mean, how many ways you can arrange some numbers where the order is important, and C, the order is not important, which is number 3. Which is 362,880. Okay. Number 44, you are dealt 1 card from a standard deck of 52 card deck. What's the probability of being dealt an ace or a 7? Okay, we have 52 at the bottom. Okay. How many aces and how many 7s would work in your favor, guys, here, which is the numerator?
There's 4 of each.
4 of each, exactly. For students who don't know about standard deck of cards, there are 4 of each, so it's 8. And that's the answer. So if I give you, for example, 44 on the test, and I said, find the probability of being dealt a king or a queen, that's 4 plus 4, which is 8. A king, 4 out of 52. 45. In interpreting a box plot of a data set, we know that the median is to the left of the center of the box, and the right line is longer than the left line. So this is what we have. Something like that. Oh, to the left of the center. Sorry, the median is not here. Sorry. Forget about this, guys. The median is right here. That's the median. Okay. What can you conclude about the data? Either symmetric skewed right or skewed left, guys. Which one do you think? There's a tail, longer line toward the right.
Skewed right.
Skewed right. Yes. I agree. And remember, guys, the mean is bigger than the median when it is score right. And look, this is why the median is sitting on the left side and the mean is on the right side. And 46, identify the sample space of the probability experiment, tossing 4 coins and recording the number of heads. So the number of heads, when you toss 4 coins, how many possible heads could you get? Do you guys agree with me that what would that be? How many heads could you get, just when you toss 4 coins? Is it possible that you see no heads, all tails? Yes. So it could be 0 heads, it could be 1 head, it could be 2 heads, it could be 3 heads, it could be 4 heads. It's unlikely that you see 4 heads at the same time. The probability is going to be low, and it's unlikely to see 4 tails. This is probably more likely to happen than the first one. So that concludes the study guide, the first one. And you guys, you have the second one. I would like you to go over it probably on your own. And I will see if I can bring some more hints to the second study guide later. And